Hey guys, Jim Vanosky with Manufacturing Talks. On most of my shows, I talk about things being so educational because I get to talk to so many cool people with so many cool stories. Today's is particularly illuminating because I actually learned something very important myself, and that is the difference between computer chips and the printed circuit boards that they go on. And I've got a true expert on that, David Schild. He is with the Printed Circuit Board Association of America, and he's here not only to educate us about what they are, but also to impress upon us the importance of making these for ourselves here in America. So stay tuned. We'll have David in just a minute.
Welcome to Manufacturing Talks with Jim Vanosky. Industry has a million cool stories, and Jim talks to the movers and shakers who are making them happen. Let's dive in.
Hey, everybody. Welcome back to Manufacturing Talks. I'm Jim Vanosky, your host. Really glad to be joined by David Schild today. He is the Executive Director of the Printed Circuit Board Association of America. Welcome, David.
Thanks for having me, Jim. I appreciate it.
Yeah, thanks for joining us. This one's going to be educational, I think. So before we dive into the meat of the subject, why don't you just tell our listeners, our viewers, a little about yourself?
Sure. So my background is government relations and communications for some large aerospace companies you might have heard of, TRW, United Technologies, and Raytheon. And out of that background in Washington, I now find myself advocating, educating, and hoping to legislate for the microelectronics industry, specifically printed circuit boards and integrated circuit substrates.
And you are with the PCBAA. Tell us a little about that.
Sure. Well, founded about 3 years ago, the Printed Circuit Board Association of America has about 55 members. We represent the folks that make printed circuit boards and integrated circuit substrates, as well as their critical material, refined material suppliers, assemblers, OEMs, everybody in this value chain that's contributing to the electronic devices that make modern life possible.
And like a lot of areas of industry, we're going to be diving into some things where a lot of this stuff went overseas and there've been various efforts to bring some of it back and shore up what we do for ourselves. But one thing I already had an education on is we talk about printed circuit boards, and then everyone, I think, also kind of thinks about computer chips and really doesn't know the distinction. I know I didn't. I got educated. So why don't you lay that out for us right up front?
Sure. Well, what we like to say is chips don't float. There's been a real focus because of the Chips and Science Act
Right.
on semiconductor manufacturing in America. And if you look globally, the U.S. only makes about 13% of the world's semiconductors today. And semiconductors can best be thought of as the brains of the operation, right? In any modern electronic device, you're going to have a chip or a semiconductor that is going to essentially run that system. And what we're advocating for, what we're trying to represent, is the rest of the microelectronics stack. And so underneath the chip, you would have what's called an integrated circuit substrate, a layer of material that then connects it to a printed circuit board. And PCBs, which are sometimes perceived to be green pieces of plastic, are in fact sort of a complex laminate of copper, other precious metals, woven glass, solder. They're engineered in such a way that they're designed for the specific end use application. They're not off the shelf. They're all custom for everything from F-150s to F-35s. And so we think it's important that folks remember that if we only have 13% of market share in semiconductors, that's a point of concern, right? We've got economic and national security issues that tie back to that capacity. The reality is we only have 4% of the world's printed circuit board market made here in America, less than 1% of the world's integrated circuit substrate market. And that is a steep decline, Jim, from where we used to be. At one point, around the year 2000, we had 2,200 companies making PCBs in America. That meant 30% of world market share was produced here at home. Today, it's less than 150 companies and 4% of market share. So there's been a very, very steep contraction over the last 3 decades. That's what we're here to reverse.
So I have to admit, as I was thinking about that clarification between the computer chips and the PCBs, I think my brother Steve, who's this uber geek, started his career making PCBs for Texas Instruments. So let's keep that from him, that I didn't actually know what he was doing a few decades ago.
I'm new to this industry myself, and so are notably a lot of policymakers in Washington.
Yeah. Well, and that makes sense. This is certainly an area of extreme specialty, like you said, it's all custom, and
Yeah.
I think that's what a lot of people need to understand is how critical it is to have that ability to do those custom manufacturing tasks. So you talk about we had this substantial market share in America and it went away. So what happened?
Well, primarily it went overseas to Asia, and there were a lot of reasons for that. Obviously, there's a lot of low-cost manufacturing that's moved overseas. Just the general globalization of the economy and manufacturing specifically, certainly not unique to our industry. The thing that I like to point out when we talk about this term industrial policy is that other countries have been engaged in it for decades. If you read Chris Miller's book, Chip War, which is really the definitive history of how semiconductor manufacturing went overseas, you'll see that it's no accident that certain nations dominate these market segments right now. They made decisions in Japan, in Taiwan, in China, in the Philippines that they wanted to do more microelectronics and high-tech manufacturing. And as a result, you saw government actions to drive that outcome, right? You saw land giveaways, you saw infrastructure construction, you saw workers subsidized housing. There's any number of examples that gave those nations a competitive position. And then, of course, once price advantages were achieved, it became very difficult to retain market share here in the United States. But this is not a game that we have to concede. It is not a place where we have to throw up our hands and say nothing can be done. I think the CHIPS Act is proof positive of that. Some of this work has gone overseas, but a rebalanced global portfolio is possible.
So I personally engage a good bit in public policy discussions, and to me, there's always a bit of this tension between what you talk about around industrial policy and yeah, I mean, we've seen our position here just enormously erode, and that is definitely a problem, if only from a national defense perspective. On the other hand, you mentioned Japan, and broadly speaking, I would submit that their industrial policy kind of failed over the decades. They're not what they were when we were worried about them back in the 1980s. So how do you strike that balance between the government picking winners and losers, and oftentimes poorly, versus shoring up our core abilities to make for ourselves?
Sure. So there's a couple of things to consider when we look at, how we're going to behave on the global stage. I think the first thing to remember is that we're playing catch up, right? If other nations have chosen to, create incentives and attempt to capture and own marketplaces, I think that's a geopolitical competition that we're engaged in. And everybody acknowledges that, right? You see it in any number of manufacturing sectors. I think the other thing to remember is that there are legitimate economic and national security reasons why we don't want to be dependent on foreign sourcing for microelectronics, right? And I don't want to throw any particular industry under the bus here, but there are certainly other segments of the economy where we rely very heavily on imports and foreign manufacturing. And I don't think it translates into scarcity, into national security risk that you might see in the microelectronics space. Why do I say that? Well, because obviously in the aerospace and defense market, we're critically dependent on these technologies. But then when you expand that aperture a little bit and you get out into critical infrastructure, let's talk about things like banking servers, hospital operations, medical devices, the power grid. Certainly the vision in the United States that we're going to electrify the economy and build more wind turbines, the fact that we're going to build more EV chargers, none of this is going to be possible without a very steady and reliable supply of microelectronics.
Right.
You don't have to look far to see that supply chain disruptions are really just a matter of if, not a matter of when. There are man-made and natural disasters that we've seen over the last 5 years that have really impacted the ability to not just store shelves, but produce critical goods. So I would say that the government staying out of this and watching from the sidelines will inevitably lead to risk that supply chain managers don't want to address, CEOs don't want to address, and customers don't want to endure.
Another thing that I've read about, particularly with China, is that we kind of committed an own goal here back when this stuff was all going overseas, and that we kind of allowed our intellectual property to be vandalized as well. Is that the case when it comes to PCBs?
I think this is a really important point, and my chairman, Travis Kelly, often says this, that research and development is co-located with production most often in manufacturing. So what happens when you take a factory that makes printed circuit boards or IC substrates and you send it overseas, you often lose the IP, you often lose the intellectual capital, you lose the next generation creation that's going on at that factory. So we talk a lot now about the chips that are going to fuel AI, right? Things at 4 nanometers, potentially at 2 nanometers. What's not well understood is that we're going to have to invent a new generation of support structure, right? A new technology stack. The next generation chip needs the next generation substrate, needs the next generation board. I think it's in our national interest to invent those boards here in America. And so when you move capacity overseas, when you move manufacturing overseas, you're sort of seeding the future in terms of innovation. Not a good place to be.
So one more devil's advocate question, then we'll move to
Sure.
positive stuff. So what about people who just say, well, so be it, that made things cheap and we're benefiting from lower prices?
I think all you have to do is look back 3 or 4 years to the COVID-19 pandemic and what we were not able to get and what we were not able to manufacture. And, that's my rebuttal to that argument. Not to mention that there is a concentration with our number one geopolitical rival for a lot of this manufacturing.
Right.
Look now at the fact that, we are needing to buy munition stocks from foreign nations to back up the Ukrainian government because we don't have the capacity to produce the number of munitions that are needed in that fight. That's not even a war that the United States is engaged in on the ground directly. We're supporting an ally there, and we still had to outsource a lot of our defense production. Imagine if we get into a direct conflict. Imagine if we need a surge capacity of production on precision microelectronics. That's going to be critically important, right? Something like a Javelin missile isn't smart and state of the art until you install microelectronics in it. We've got a great supply chain. We've got ITAR controls. We've got Department of Defense rules that say that some of this stuff has to stay on shore. But ask anybody to look inside their supplier, and pretty soon I think you have to face some uncomfortable questions about where things come from and what you're dependent on and what happens to the lead times when things have to traverse an ocean to get here.
Yeah, and that's something that we've talked about here in any number of corners of industry. Is it, going back to your point about COVID, we all saw how these round the world supply chains failed, and to have all our eggs in that basket is lunacy.
Sure, I agree.
That being said, we don't have to have all our eggs in our own basket either, right?
Yeah, a diverse and secure supply chain, a resilient supply chain looks like a rebalanced portfolio. It includes nearshoring. It includes work in Mexico and Canada. The Europeans do quite a bit of very high-tech work in microelectronics. I think when we say we only have 4%, that's an intimidating statistic. 89% of the work is in Asia. 56% of the work is in mainland China. That's dependency any way you slice it.
Definitely sobering figures. So as we look at those, then talk about maybe like the top 2 or 3 critical needs that you see where we should be taking aggressive action to shore ourselves up.
Yeah, I think what we need to do is we need to create the kind of incentives that put American manufacturing in a competitive place. Our industry has been backing for several years now a piece of legislation called the PCBs Act, or the Protecting Circuit Boards and Substrates Act. It's essentially a CHIPS bill for our industry. It would do 2 things. First, it would create a grant program of approximately $3 billion in government funding so that folks could capitalize new factories, new worker bases, new tooling, new equipment, and actually expand capacity, which, we're pretty much maxed out on right now. The second thing it would do is create a buyer tax credit, a 25% tax credit on the purchase of American-made printed circuit boards and substrates. Once that tax credit is in place, many of the boards and substrates that you're buying are now in a cost competitive position with Asian suppliers. I talk to a lot of large OEM heads of supply chain, a lot of purchasing agents, and they say the same thing. I'd like to diversify my supply chain. I'd like to do more work from more different places as a matter of insurance all over the world, but I can't because the capacity simply isn't there. Well, there's a sort of a chicken and an egg thing that happens here, right, Jim? I mean, we've got to create a demand signal. The other thing that's really fascinating about this argument is, people talk about the government picking winners and losers. The private sector, and specifically private investment money, it follows public action. What's remarkable about the CHIPS Act is not necessarily that the government invested $52 billion, right? The government can spend that kind of money. It's that by some accounts, between $400 and $600 billion in private money has come off the sidelines for semiconductor capacity in America because of the CHIPS Act. Once Wall Street, once the private equity community, once the investor community sees, hey, the government has its hand on the scale here, the government is trying to incentivize this production, private money flows into those kind of sectors. I think the same thing will happen for the rest of microelectronics, but we need that demand signal first. We need action by the Congress and the president.
When you look at that kind of investment, following investment, one concern I have is that we're kind of already behind, and the government goes into a sector of this that in fact is already moving toward obsolescence. How do you avoid that kind of problem?
It has taken us more than 3 decades to dig this hole, and I don't think we're going to dig out of it in 3 weeks or even 30 weeks, but the time to
Yeah.
start is now. I have a lot of respect for what the semiconductor industry did, right? They got out there, they made everyone aware of how critical their technology was, and they made convincing arguments in Washington that now are leading to groundbreaking factories in places like Ohio and Arizona. We can do the same thing for the rest of microelectronics. It's not too late, right? We've gone from 2,200 companies to 150 companies, but those 150 companies are strong and vibrant, and they're best in class, I would say, from a technology perspective. So let's give them the boost, the support that they need from the federal government. And I think we'll see more work here in the United States.
So kind of flipping that on its head, then my previous question, there are obviously startups out there that
Mhm.
are aiming at what's coming next. How do we help support them?
Well, you're already starting to see that. We talk a lot about substrates. And in fact, the US makes less than 1% of the world's supply. The Japanese dominate that market. But I know in places like Arizona, you have new startup companies that are trying to chase chips money, that are supporting our association's work. And they believe that they can manufacture in a cost competitive position integrated circuit substrates here in America. I think there are emerging technologies by way of printed circuit boards. You see some of this in flexible circuits. You see this in things like ultra high density interconnects. The board makers are not sitting still. They want to innovate, whether it's a new small startup or even some of the larger companies out there that understand the technology has to evolve. So I would say it's a great time to be looking to make things in America. I mean, the manufacturing statistics quarter over quarter, you know this better than anybody, Jim, are trending in the
Yep.
right direction. Some of that is fear of dependence on foreign sourcing. Some of that is just still lagging interruptions for the last 4 years. But I also think there's a recognition that we've done this before, right? We've had manufacturing ecosystems. The example that I use very often is automobiles. When we had final assembly of cars in Detroit, we had transmissions coming out of Ohio, we had wiper blades coming out of Indiana, we had brake pads coming out of Illinois. We had these nodes, as Secretary of Commerce Gina Raimondo sometimes says, of manufacturing. There's no reason an Intel factory in Chandler, Arizona cannot be surrounded by a substrate factory and a printed circuit board factory. And in fact, an assembler of populated boards who then goes on to an OEM who produces an end product. We don't need to have 100% of that market, but we can have a lot more of it than we currently do.
Right. Yep. And so you kind of allude to the manufacturing halo effect of these other businesses riding on that main driver. Is there anything like that? We kind of distinguish between chips and PCBs, and we all know about the CHIPS Act. Is there any kind of halo effect, in the absence of the initiatives you talked about with the CHIPS Act around maybe driving some of that broader development for PCBs?
So we're only in the second year really of CHIPS Act implementation. And what we're seeing is that the semiconductor industry is benefiting most directly from those dollars, right? Intel, Micron, TSMC, a number of other companies are at work building factories in the United States. I would say we haven't seen a downstream benefit for the folks in my industry yet, other than a sense that it's possible to make things in America and it's possible to do high tech manufacturing in America. It has changed the way of thinking in the federal government. And when I talk to state lawmakers, when I talk to local chambers of commerce, they're much more open-minded to creative incentives to bring that kind of business to their area. How transformative is it going to be outside of Columbus, Ohio, or Phoenix, Arizona, if you have thousands of high-tech manufacturing jobs that otherwise wouldn't have been there? It will create, I think, an appetite for more of this. And I'm seeing that with public officials. They're curious about what else might be coming.
Yeah. Well, and I cover all of industry very broadly, and it's become a very typical conversation around the workforce challenge is that we have to
Mhm.
educate people that manufacturing is not the dark, dirty coal mine of the world
Right.
that it
Exactly.
was, generations ago. And this kind of thing certainly helps us with that marketing.
Yeah, I think that if you were to go into a PCB factory, you'd see a lot of what I would term as industrial processes because we're plating, we're using, pretty harsh chemicals to get a lot of this work done. But you're also
Yep.
going to see a lot of high touch labor. You're also going to see a lot of automation. You're going to see a lot of what I would say is leading edge technology because of where this stuff is going, right? It's going up to orbit. It's going into electric vehicles. It's going into, again, the smartest and most leading edge systems that we have inside the United States military. So there is not always that bunny room, clean room effect that you see in semiconductor manufacturing, but it is a mix of engineering processes. You'd be impressed by the workers and their training and what they're doing. And I think you'd be impressed with just the level of detail and the level of concern because this stuff has to work. In many of the critical applications where a printed circuit board ends up, it's a zero fail environment, right? And so I think, there are plenty of children's toys filled with PCBs, but you don't get on a plane that's not full of PCBs. You don't pick up a phone that's not full of PCBs.
Right.
Our industry understands the focus on what they're doing, and I think the engineering supports it.
Yeah, well, and it's certainly not getting any smaller either, right? You talk about all the AI and the further
Mhm.
automation in all facets of society. So the number of chips isn't going down by any means, right? Or the number of PCBs, I should say.
I think that the Internet of Things, the general, push to connect things and put things online. There are certainly many more products today. When I walk into congressional offices, I point to the light bulbs and say,
Right.
years ago that didn't have a PCB, but now it does because it's LED driven.
Yep.
It's very hard to get through your day, right? From your alarm clock waking you up to that light that you turn off at night, you've probably interacted with microelectronics during the entire day. We like to say PCBs make it possible. They're just a ubiquitous part of life at this point.
When we talk about what you guys do, obviously we've hit on quite a bit of government lobbying, but there's also education to be done with business people, with the general population. Does the PCBAA associate with that kind of activity as well?
Our primary focus is in Washington. I will say that a lot of these activity that you see us do around the scholarly community, the academic community, the think tank community, policymakers in Washington, the media, it's designed to serve a broad audience. I give a lot of credit again to the chips guys. For years and years, you saw that Intel tagline on ads for Dell computers, and it really was an effective way of co-branding and letting people know, hey, there's a semiconductor at the heart of this product that you're buying. I don't think the general public has a good understanding of PCBs, and that's a
Right.
problem that we need to solve for. Our primary audience right now is lawmakers, policymakers who can actually bring money and other incentives, and we think positive initiatives to our industry. And of course, as a part of that, there's some education going on, but we're still small, we're still lean. I'm not sure we're ready to run that Super Bowl ad explaining to the average American what a PCB is yet, but we'll get there.
Yeah, well, I can't say I'm giant either, but I'm doing my part to get the word out there. So we all have a part to play, right?
Absolutely.
So you're small and you've got out of the gates here in the last few years. Looking forward, next 5, 10 years, where do you see your organization going? What are going to be the continuing priorities as you move ahead?
Sure. We're always focused on growth, and I'm very proud that we've gone from 5 to 55 members in less than 3 years. There are hundreds of companies out there that I think should be on our team, and the larger we get, the greater the political footprint we have. So growth is clearly a priority. The issues of government support for microelectronics manufacturing and industrial policy writ large, those are always going to be there. And I'll give you an example. We've got some language in the National Defense Authorization Act. That's essentially the bill that tells the Pentagon what to do, that says by 2027, they've got to look inside their supply chains and they've got to remove microelectronics from prohibited foreign sources, right? Countries like Iraq, Iran, North Korea, China, Russia. And guess what? That is still 3 years away at this point. So we have got to stay on duty and we have to watch that program and make sure that it gets implemented. If we're successful in getting government incentives, our own version of the CHIPS Act, we of course have to have a keep sold fight that happens there. And I think you'll see us probably expanding our efforts out into the states and localities to do a similar educate, advocate, and legislate mission. So there's no shortage of work ahead of us. We're not planning to turn out the lights or roll up the carpet anytime soon. The industry, I would say, was a little late to the game in Washington, but we're here now in an established way, and we intend to stay.
Is there anything and that is pretty substantial membership growth, even though you do admit you're still a small organization. What are the main messages to those members as they come on board? Is it about the lobbying? Is it back to the industry? What do they need to know as far as the priorities for private industry?
Sure. So I talk to folks making microelectronics all over America every week, and the message is usually the same, which is we want to do for you what the CHIPS Act did for the semiconductor industry. We want to educate, advocate, and legislate on your behalf. If you're out there running a $40 million or $400 million microelectronics shop, you have to focus on workforce issues. You have to focus on quality control. You have to focus on state-of-the-art manufacturing. You don't have time to worry about media campaigns. You don't have time to worry about public relations or Washington advocacy. So guess what? Our association will do that for you. We'll be your voice in Washington. You can stick to making world-class microelectronics.
Good deal. We're just about out of time. Any parting thoughts? Anything we didn't hit on that folks out there ought to know?
No, I would just say that I'm optimistic and our industry is optimistic about what's possible. Just over last weekend, you saw the federal government pass a number of bills to keep the government operating, right? The fiscal 24 appropriations bills. What most people didn't realize inside that billions and billions of spending was there was almost $587 million in something called the Defense Production Act account. That's essentially the way that the Pentagon invests in leading edge microelectronics. Our industry fought very hard to protect that money and, in fact, grow the amount that was in the final bill. There is opportunity everywhere across the federal government to support our industry, and we've had some very significant wins. Just the President of the United States a few years ago designating PCBs as a critical national security technology to drop red tape, to speed acquisition. That was a huge win for us. So we've got a lot of points on the scoreboard just in the last 36 months. And, I would say to your listeners, this is a segment of manufacturing that can surge again in America. We want to get more people on our team and continue the fight in DC.
All right. Well, excellent. David Schild, thank you for joining us. This has been what I thought, very educational and illuminating.
Thanks, Jim. I appreciate it.
And of course, as always, thanks to our viewers and listeners. You guys are why we're here. And I hope you found this as illuminating as I did. I can't promise that every guest is going to be as illuminating as David was today, but they're all going to be illuminating. We're here every Tuesday and sometimes more often. So keep tuning in and we'll keep churning them out. Thank you.
Thanks for tuning in to Manufacturing Talks with Jim Vinosky. Watch for new episodes dropping every Tuesday. And don't forget to like, share, comment, and subscribe.